So I swear this is the last time you're going to see me. And we are going to talk about an introduction to property-based testing. So yesterday we had Natalia who told us about snapshot-based testing. And this time I want to talk to you about another paradigm that you can use in order to basically enhance your testing game for your iOS app. But first, let's talk a little bit about what we could call a classic unit test. If you take any textbook or blog article about unit test, you're probably going to find those three words: given, when, then. That's because when we write a unit test, we tend to follow the following structure. We're going to say, given some state, when I perform this action, then I expect that result. If we try to write it in XC test for our iOS app, it's going to look something like this. For instance, we are going to test for valid data. So we're going to say, given a set of valid data, when I run my business logic, then I assert a result that meets the expectation, which are probably the business requirements associated with my logic. And the same way, we are going to also write a test for invalid data. We are going to say, given my invalid data, when I run my business logic, I want to make sure that, for instance, the error or the exception that is thrown correctly and is handled correctly. So this is a slide where I really get to show off my designer skills. So this is supposed to be a Venn diagram. This is like the set of all the data you could have in your app. In green, you have the valid data. In red, you have the invalid data. And in the code I've shown you, basically what I've done is that I have picked a point in the valid data. I picked a point in the invalid data. I said, OK, I'm testing for these 2 points. And I'm kind of assuming that these points, they represent the whole area that they are in. But inside our apps, the bugs, they often lie on this line. And this line basically is the edge cases, is the special values that are going to have some unexpected behavior that are going to make your app crash in ways that you didn't anticipate it. And classic unit tests, basically they're great at catching regression because they are deterministic, they always work on the same values, so we can trust them to catch a regression for a set of data for which we have written a test, but they will not allow us to learn anything new from our app. And it makes sense because they're deterministic. They're always supposed to return the same result. And the question that I want to ask and try to answer today is, could tests discover edge cases? How could they do it? And a way that they can do it is simply by saying, OK, in a classic unit test, we start with the data given, and we try to assert a property, the then part. What we are going to do is that we are going to switch it around, and we are going to start with some properties, and we are going to try to find data that break those properties. And we are going to hope that those data that break the properties are our edge cases. So to make it a little bit more clear, I'm going to start immediately with an example. So let's consider this very simple function from the standard library. It's the function reversed on array. What it does is that it takes an array as an input, so it's an instance method, and it returns an array where the elements have been reversed. So first one has become last one, etc. How can we define a property on this function? So we can do it using natural language. For instance, we could say if an array is reversed twice, then the result is equal to the input. It makes sense. If you reverse something twice, you get back to where you started. We could also rewrite it a little bit to make it a little bit more mathematical. Maybe we could say that any array reversed twice is equal to itself. Or if you have some memories, fun memories or bad memories of first-order logic, you know that we can write it like this, which means the same thing than just before. It means for any A, which is an array, if I call reverse twice on A, then I get the same result. So reverse of A is equal of A. So how can we write this in code? We can do it using functional programming. Basically, if we write this function, you can see that the input of the function, the argument, they correspond to what we could say the quantified variable in the formula. And the condition is the return value of the function. So we can write properties in code, and we can write them quite easily. Now, how can we have a testing engine operate on them and find edge cases? So what I'm going to do, I'm going to show you basically property-based testing in a nutshell. What does it look like? So remember, for classic unit tests, we had this three word, given, when, then. Here is the same idea. We have three terms. It's for any, such that, and property. So a property-based test, you can write it by saying for any input values x, y, z, such that a certain precondition on x, y, z is satisfied, then a property must be true. If we apply this to the example of the reversed function, we could say for any input value array, the property array.reverse.reversed equals array must be true. So pretty simple. Now, how can we implement this in Swift? So in Swift, we're actually quite lucky because there is an open source framework called SwiftCheck that is available. If you know Haskell, you might know about the framework called QuickCheck. It's a Swift adaptation of this framework. And it's a framework that's going to let us write and run property-based tests. And it works by following a very simple set of rules, actually. What it's going to do is that it's going to test the property that we write, and it's going to run them using input values. Then, if the property fails, meaning if we have found an input for which the property is not true, it's going to try and shrink the responsible input until the property no longer fails. And the idea is that if everything went well, it's going to return OK. And when there is an error, by this shrinking mechanism, it's going to be able to return us the smallest counterexample, the idea being that the smaller the counterexample, the more actionable it's going to be for the developer in order to debug and to understand the issue. If you have a bug on an array that has 1,000 elements or 1 million elements, very hard to do something with it. If there are just 3 or 4 elements, it's much easier. So SwiftCheck, it actually works with this protocol called arbitrary. In order for a type to be arbitrary, it needs to implement two things. It needs to implement a generator, so a way to generate random data, and it needs to implement a shrink function. It's the function that's going to try to reduce the data into an array of smaller data. So the nice thing is that for all the basic types like int, strings, etc., it's already implemented by the library, so I'm not going to focus too much on it. Instead, I'm going to show you how you can write a first property using SwiftCheck. So this is what it looks like. We can see that you have a function called property. We give it the name of the property, so it's the simple test of an array reversal. Then we have some custom operator, and then we use, like we said, for all the quantifier to say for all array, I want to assert that the property array.reverse.reversed equal array is true. And that's it. You only need to write this, and when you would run your testing code, well, just like standard testing function in XCTest, this would run. The framework will generate values to try and break the property. Of course, it's not going to be able to break it because the standard library works fine, of course. But this is the general idea. So now that we've seen a very simple case, we're going to try and define a property that is a little bit more complex, meaning a property that has a precondition. So now this time we want to test that the elements are actually reversed in the array. So we can write it as it's written below. We can say for any input values array and I, such that the array is not empty and that I is within the range of the array. Then we want to check that when we reverse the array, if we get the corresponding indices by mirroring on the array, we get the correct element, meaning that the array is correctly reversed. So when we try to write it, it's a little bit more complex. We're going to take a look at it step by step. So the property, we are trying to test that the elements are correctly reversed, and as an input, we have an array of integers. We start by saying, OK, we said the array must not be empty. So we say, if the array is not empty, then it implies another property. This is how we write the precondition. Then what we do is that we get a random index, but we don't want just any int. We want an int that is a valid index for the array. So we do it using the helper function gen from elements, and the elements being the indices of the array. And then we return another property, so it's kind of a flat map. This property, this time, its input is the index, because we said we had two inputs, the array and the index. And inside, we write the condition that was written in natural language just before. So array.reverse of index is equal to array, etc., etc. So it's a little bit kind of a lot of code, but that's the way that you write it. And just as before, when you are going to run this test, it's going to generate random arrays, it's going to find random indices, and it's going to try and find a situation where the elements are not reversed correctly. So once again, the standard library does work, so we won't find an error. So now we're going to try and actually catch a bug, and to do it, we're going to run property-based testing on code that doesn't work, so code that we're going to write ourselves. So let's say we have the following requirement. We need to validate email addresses. So using a regex, it's something that you find in most apps. Whenever you have an enrollment process or a page to sign up, you need to put your email address, and you want to validate that this is indeed a correct email. So since we are developers, we are lazy. We are going to ask Google for a regex. But since we are mindful developers, we're not going maybe to take the first result. We're going to take the second one. So we're going to find something like this, some regex that we don't understand. We don't want to spend time understanding it, but maybe we would like kind of have some trust that it works. So how can we test this regex using property-based testing? First thing is we are going to encapsulate this regex in a next function that takes as an input a string and returns a Boolean. This way we have a nice interface to actually call this regex. And then we are going to create a generator of email addresses. So in order to understand how you build an email address, you go on the internet, you look at the RFC for email addresses, and it tells you which characters are authorized and which are not. So we will read, for instance, that you can have uppercase characters, you can have lowercase characters, numeric characters, some special characters. And then we are going to build some generators. Then we are going to glue them together, to combine them together in order to generate what's called the local part of the email. So it's everything that's before the @ sign. So to do it, we say, OK, it can be basically the content of the local part of the email can be an uppercase character, a lowercase character, a numeric character, or a special character. We don't want empty local part of the email address. So we say purify only the non-empty values. We also add a condition because it cannot end with a dot. That's in the RFC. And finally, we map the array of characters to a string in order to get a type that is more easy to manipulate in Swift. Then we do the same thing with the other part of the email address, so the host name and the part that's called the TLD, so it's the domain name, basically. Once we have this, we also give some arguments to SwiftCheck. For instance, we're going to say, don't try email addresses that are bigger than 10 characters, because we're going to see we don't need to go up to 10 characters to find a bug. And then we actually write the property. So does our regex work? So we write the property, we provide our custom arguments. We say, OK, it's for any value that comes from my email generator. I want to test whether it is a valid email. And since my regex only validates valid emails, everything that's come from the generator should return true. And I'm not going to try to shrink it, because shrinking an email address is a tricky process. And since it's not going to be bigger than 10 characters, I don't need to shrink it. And if I run this code, actually, after only 2 tests, it's going to find that my regex doesn't work. Actually, this email address, pipe@o.az, it's a valid email address given the RFC. And the regex that I found tells me that this is not a valid email address. So it's kind of bad, because maybe someone has this email address, and I'm not going to allow him to sign up to my service, so I'm going to lose a user. This is bad. And since we are starting to get into systems like sign in with Apple, where you have an email address that masks the actual email address, it makes sense that you need to be prepared for weird email addresses, because they are going to be computer generated. So being able to find such cases is pretty cool. And yeah, we managed to catch a bug with a test. So the system does work. We can catch bugs. We can catch edge cases with property-based testing. So it's kind of cool. So now that we have seen this, you might be thinking, OK, can I also test for invalid emails? Actually, you cannot. Because remember, property-based testing for any value such that a precondition is met. If we wanted to test for invalid emails, we would need to have a precondition to tell valid and invalid emails apart. And this is what we actually want to test. So we cannot use property-based testing to test for invalid emails. And actually, I find it interesting, because it shows us that property-based testing is not better than a classic unit test, the same way than a snapshot test is not better than a classic unit test. There are options that work together, that have advantages and disadvantages, and it actually works really, they actually can work very well together. So to keep on going, I'm going to show you how you can mix both approaches. And we're going to take another example. We're going to imagine that we have a function that computes the average of an array of double. Very easy to understand. And basically, for such a function, we might want to use good old database testing. So given a set of input, I am expecting this result. It's very easy to test that for some known value, we indeed have the correct result. But when we have, for instance, an average is something that has properties because it's a mathematical thing. For instance, you might have something like the average of products equals the product of the average. This is a property, and this is something where property-based testing is going to help us a lot because we can say, okay, basically I can write a property where I compute the average of the product, I compute the product of the average, I make sure that both are equal, and then my framework is going to run this property on many values, many more than I could have ever thought of. And if the property holds, if it finds that the property holds with many values, I can be confident that, yeah, my code is actually correct, and it basically, the properties that it should be valid are indeed valid. And we could do the same thing. We know that the average of sums is equal to the sum of average. We can do the exact same thing with property-based testing. So now, I think that some of you might be thinking, okay, this is nice, this is low-level stuff, this is mathematical stuff that I do not use in my daily life. How do I use this in my app when things are messy, when I do front-end, when I have weird business requirements? And it's a very good question. And I want you to consider maybe easy. I wanted to say that properties, of course, they are easy to define when we consider the lower level of an app, because in the lower level, we are very close to basically to math, and properties come kind of naturally in this domain. But as we get closer to business requirements, yeah, things get messy pretty fast. We have some weird cases. It's not always clear. But I want you to consider, for instance, the following property. It looks kind of trivial. I'm just saying, OK, I take an input, I run my business logic, I return true. This seems rightfully very trivial. However, it actually asserts two very interesting things. It asserts that the function myBusinessLogic does return, meaning there is no infinite loop, there is no Stack Overflow. And it also asserts that the function does not crash. And these are two properties that we want in our app. We want them to never loop, and we want them to never crash. So first, it's pretty useful for something so trivial. And it's actually so trivial that you could even have a code generation tool write it for you. Like if you have all your business logic in some nice classes, you could iterate over the classes and write the test automatically. And you're getting some pretty good testing coverage for free. Of course, you're not testing your business requirement, but you are testing that your app does not crash or does not halt. That's kind of nice. And actually, trivial properties, they make sense in other contexts. For instance, consider UI testing. In most applications, it makes sense that no two views should overlap. This should be considered a bug. We know that UI tests are hard to write and hard to maintain and long to run. But the properties just above, it's quite easy to implement it using property-based testing. We just generate random models for our views. We fill up the views using the model. And then we iterate over all the subviews, and we check that no two of them are frames that overlap. And that's it. With a trivial property, we've checked that we don't have some weird glitch in the app. So thank you to Pierre Felgines, who is a colleague from Lyon. He's an iOS developer for this cool use case, because this is not my idea, but it's a very good idea. I think it can help you a lot in your app. And basically, you could be thinking, OK, when is this approach relevant in my app in a more general sense? So I've tried to list some use cases. So whenever you are getting external data, whether it is a user input, a web service, you cannot predict what is going to happen. So property-based testing is kind of cool because it's going to help you anticipate the amount of data that you can get. Whenever you do also encoding and decoding, it can really help because this is somewhere the kind of computation where there are lots of properties that come naturally with the domain, like what has been encoded and decoded must be equal to the original material, this kind of thing. When you have regular expressions, of course, we thought it works well. If in your app you need to implement some custom sorting algorithm, you never know if you've made a mistake, property-based testing works very well because asserting that something is correctly sorted is a property that is very easy to write. If you have time zone and that arithmetic also kind of hard to test, but when you generate lots of data, very easy to be confident that it works. And finally, if you are an SDK developer, you know that developers, they are going to call your SDK with crazy data that you could have never anticipated, so property-based testing can be very nice in order to anticipate this crazy amount of data. And finally, you might be thinking, okay, this is cool, but this is also a lot. This is maybe a little bit overwhelming to add all of this framework with its custom syntax in my test. Is there a lighter approach to get me started? So there is one. For instance, you have libraries like Fakery on iOS that allows you to generate random data, and even random data that makes sense, for instance, first name, sentences, addresses, etc. And you could write an extension on XC test case. We could call it fuzz, because sometimes this kind of testing with random data is called fuzzy testing. What it's going to do is that basically we give it a test, and it's going to run it 100 times. And then we could write our test, just add this little fuzz keyword, write our test that is going to use random data from Fakery or from any other random generator. Our test is going to be run 100 times, so we are going to get this kind of random input. We're not going to get the shrinking mechanism or anything else, but we are still able to generate random data and try to basically to have our app feels like it's in the real world where we can't anticipate the data. And to conclude, I don't know if you've seen this film that got out a few years ago, but there is a part of the film where people say Murphy's Law doesn't mean that something bad will happen. What it means is that whatever can happen will happen. And I think we all know that it's very true for apps. Whenever we think, okay, this will never happen, then in Crashlytics we see that, yeah, it did happen. And the idea of property-based testing is saying there can be an infinity amount of data that can be given to our app. We cannot test for every single one of them, of course, but using techniques like generating random data, we can try to approximate this infinite amount of data, and we can get a better sense of confidence that our app is ready to handle this incredible complexity. Thank you.
Thank you. Thank you very much. Do you think this could work in my very new snapshot test?
Oh, I think it works very well together.
Okay. So the idea, if I get well, is that instead of testing with like the data you provide, it's more like understanding the logic and
exactly.
rephrasing it.
Exactly. You're not like fixing the data, you're fixing the properties, and then the data becomes the variable.
And the problem you probably have is, as you showed us, you can reduce the number of data that would be generated by reducing the length of the email.
Yeah.
But don't you fall into situations where you have like a lot of data to generate in order to have something that is that will cover everything?
Yeah. So of course you cannot cover everything. What frameworks like SwiftCheck work, they run the test 100 times. And then every time they increase the size of the input, and at some point they say stop, because we cannot test for everything, and we feel that 100 times is good enough, especially since it's random based. The seed changes every time that you run the test.
Oh, and that's one question from the crowd is if the seed, especially if the seed changes, don't you have some random fails, like the one iteration of the test would run and another one would fail because it would use some other...
You can definitely get into this situation because it's actually the purpose. We want to find the edge cases, so we want to find values for which the test fails. What's nice is that when the test is going to fail, the framework is going to tell us, okay, I failed using this seed. So we can then run again the test using the seed, and this time it's going to run in a very deterministic fashion.
That's really interesting.
That's actually a question by the public as well.
Yeah, that's deterministic if you can retrieve the seed.
Absolutely.
Okay, and yeah, because sometimes you have some tests that are randomly failing on the CI and you're lost. But if you can reproduce locally,
absolutely, you can reproduce it.
Is it fast? I mean, does it like take too much time, your CI, or?
It's going to take a little bit of time. So, for instance, it might be interesting to not have them always run. For instance, you might have such tests only run when you want to merge into develop or into some important branch.
Yes.
And for local builds and builds on feature branches, maybe not have them run or not run with as many data, like not 100 iterations, maybe only 10, something like that.
Yes.
Like locally, you would run for like a really long time and then just...
It would really depend on your situation, but you can really adapt it and make it work what's best for you, given your computation power locally on the CI, etc.
I see an interesting framework to test also our core ML models. Do you think that would be work? That would work actually?
It could work if you can find properties that make sense. And this is always the hard part, finding properties that make sense. Maybe there are some trivial properties that make sense in the realm of core ML, and then it would be a nice addition, but this is the hard part.
Yeah, sure.
And how far did you go in trying that in real apps or with real code? And did you?
In real apps, we haven't introduced SwiftCheck. I have some colleagues in the room. Now they are aware of SwiftCheck, so maybe we will discuss it. But the idea of using random data, it's quite useful. And the idea also of using code generation to write trivial tests, that's something that we've been using, and it's very actionable. The return on investment is very good.
Nice.
Okay.
So thank you very much.
Thank you very much for your talk. Yeah.